Hello everybody, Mr. Rubo here. We are going to continue talking 2.5 exponential function context and data modeling. And today we're going to talk about how to do a regression model using the calculator. So first thing, modeling exponential functions from data, and exponential model can be constructed if we are given either the common ratio and the initial value. If you're given those, you are golden. But if you are not, you could also be given input-output pairs, two of them at least. And that would be enough to then create a exponential model. So here's an example. For 0 to 30 minutes, the number of fans inside a large sports stadium can be modeled by this function, where F is the number of fans, T is the number of minutes after the doors open. There are 47 people in 2 minutes and 2,602 after 20 minutes. So right there we have our values. And we want to write our regression model. So you can kind of see the steps here, but I will show them in the calculator. So on our calculator, we're doing a regression. If you were doing this in Desmos, we'll show that in class, but you'd hit stat and then edit. Okay. Now you'll notice I have stuff in here from previously. So I'm just going to go over all of the values and hit delete, which is this del, right? And that lets us clear out these lists completely because I only had 2 values. So I'm going to plug both of them in. So first, my X's were at 2 minutes and then 20 minutes. And then the Y values for the 2, it was 47 people. And then for 20 was 2602, 2,602. Just make sure, again, this, as I talked about before, this is the point where most people make mistakes, is they accidentally type something in wrong. Because from here on out, it's literally just letting the calculator do the work. So if these are typed in wrong, your calculator will do the work, but it'll do it incorrectly. All right, so we're going to go ahead and hit stat after we have the data entered. Go over to calculate. And now we are told it's an exponential model, so we are looking for the one that says EXP regression, and we select that one. And L1, L2 don't need to change. If we want to store it, we can, which, storing is never a bad idea. Easiest way of storing is alpha trace, and then just choose Y1. Right? That's not always 100% necessary, but it is nice to have it because then we can use it later on. So we're going to go ahead and hit calculate, and right there is our A and our B, and you'll notice it's in that format that we want it in. Okay. So that is the actual function. And I may have jumped the gun, but yeah, you can see it right here as well. But I didn't actually read the question, which I should always go back and do. It says, use the given data to write 2 equations that could be used to find the values for constants A and B for the expression for f of t. Well, if I'm actually doing that, that would mean I'm just writing like a system of equations. So using the first point, I would say 47 equals A times B to the second, and then the second equation is the 2602 equals A times B to the 20th. That is actually the equation there, but we have this regression model we can also use, and again, we get the same thing here, so I don't have to go back to my calculator. So if they wanted the regression model, we do that, but I actually went back and reread the question. It wants us to write 2 equations that can be used to solve them. These are the 2 equations. Substitute y and x, y and x. All right, well, that's it for today's video. Thanks for watching. Have a good